All right, so we got some of the basics down. Now we can kind of circle back around, maybe go over a little bit more. This is a, what kind of micrometer? 0 to 1 micrometer. And what do you think this 0 to 1 micrometer reads?
0 to 1 inches.
What does it read right there?
100,000 or thousandths of an inch.
Point.
You're talking about that, sorry.
Yes. Does it literally read?
Yeah.
0.1, then 0.25, 0.011, and then probably, okay, 0.0008. Okay. That is a 0 to 1 outside micrometer, to be very specific. And sometimes it's good to be specific. I am not one of those people. If you come up to me and say, hey, I need a micrometer, if we were working together in the shop and on the same team, I would say, be more specific, or what are you measuring, or something like that, to get an idea, because there's obviously a lot of them. There are a lot of them. 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. Also, there's digital micrometers, which we're not going to use in this class, so you get used to reading the analog one. And what are these right down here?
Standards.
The standards, or gauge block, and they are used to calibrate. And how often do we calibrate these typically? At least once a year, at least. And these also have to be calibrated, the standards. So you can calibrate just the standards once a year at a calibration shop, and then you can use those to calibrate your own micrometers. So, all right, so if you were to come up and say, hey, Kevin, or not me, because somebody else, I need a micrometer. We used to have a tool room guy who was a jerk. And he would give you a micrometer, which looks something like this. Here's your micrometer. And so that is, in fact, a micrometer. So that's why we would specify, I need a 0 to 1, a 1 to 2, 2 to 3 outside micrometer, because there's also a thing called an inside micrometer. All right, and now that we've already learned how to read it, this is the sleeve, that's the thimble. We should be able to read these like that. So what does this one say? 0.3. How many lines? 0.025, 0.014, and that right there is going to be about 0, 0, 0. I heard 6. I'm going to go with it. So 6, 9, 3.3396. All right. This is another way you may see it written out on paper, because it's a three-dimensional object. And what do we have here? Assuming it's a 0 to 1. 0.2, 0.025, 0.001. No, we got too many zeros over there. And then we have a vernier scale, which lines up on the, well, it lines up on the 6 and the 2. Which number am I going to pick? 2. Well, when in doubt, I could always look at it down here and go, well, that right there is 5, so it's clearly not 6. So we're going to use the 2, not the 6. So 0.002, 0.02, 2, 6, 2, 2, 0.2262. All right. I borrowed my coworker's C clamp, and he got mad at me. That is a calibrated C clamp. If you don't know what that is, then if you really want them to work well, you got to put a vice grip on there. And if that's not funny to you, it will be someday. All right.
Is that something you fight someone over?
Ask him to buy me a new one. Lock my toolbox. Say, you're not borrowing tools anymore. All right, we also have inside micrometers. Outside micrometers are used outside. Inside micrometers are used inside. So here's an inside micrometer set, and you have to set them up. And if you are going to use one of these and you need help setting it up, I will be happy to do it. They can be a little bit complicated to set up because they have all different types of parts and pieces. Like here's one right here. If I put this in here, this would be a 0 to 1. Get in there. Trust me, 0 to 1. There it goes. And you have to make sure that is all the way down. You can't put it halfway up and lock that in and go, well, look at that. Now you just made it some unknown thing. Don't do that. All the way down. So that's a 0 to 1. You could add a 1/2 inch spacer to it. Now it's, was that 1.5 to something? Yeah, it starts getting goofy. And when it starts getting goofy, sometimes it's easier to not read it, but to actually take a micrometer and measure what you got. So the way this one works, as an example, let's see. This says 4 to 6 on it. So that would measure 4 to 6 inches apparently. And if I wanted to measure this big old opening down here, I would put it in there. And I like using these for something like this measurement. And so what I'm going to do, and it's very difficult for me to explain in a classroom setting, but this right here is the flange. And I just point that out because I can see the flange very easy. And I always want something that's repeatable. And so what I will do is I will stick this in and put it right in line with this flange because I can see that. And what I do is I put it in there and I hold it right here and I twist this out and I go through it and then back through it. So you're going to get to a point, obviously that would be too big, that would be perfect, that's too big again. Follow what I'm saying? So not only do I have to have it this way in there, I have to have it this way in there. And so if you unscrew it very slowly, you will get to, if it's too big, it won't go through, right? It just kind of stops. It's going, well, that won't go through anywhere. But as you make it smaller, you eventually find a spot where it'll go through just very little, with a little bit of drag going through. So, like I said, it's kind of hard to explain as I'm standing here. But the point is, you get it in there, and I can help you with it in class. If you're using that, go, hey, how'd that look? And when 2 people are working together, I'm working with them, like, yeah, that feels perfect. And we can work on it. But anyway, you can find just that right little sweet spot where it just goes through and drags just a little bit in one spot, drags a little bit in one spot, like that's perfect. And then you can read it direct off of here. The problem with this is, my opinion, every time you change something, it's not really calibrated. So you have to be very careful. It's like, how do you calibrate this? Well, you take a calibrated micrometer and you measure what you just got. And if the two match, then it's calibrated. So you can read it direct off of here, or you can turn it around and use a calibrated micrometer and put that in there. Get just right. And say, there we go. And read that. You can see what it says. You go, oh, okay, that's 4 point, that's 2520, so you got that. So follow?
Yeah. So I guess you're saying theoretically that doesn't have to be calibrated if
No,
you
I'm
use
saying
it.
theoretically it's not calibrated. It's not. Oh, but does it have to be?
No, but it doesn't have to be if you use an outside micrometer afterward.
To calibrate it.
So can you, if you did an engine rebuild and you had to do an inside measurement like that, could you, and you didn't have a calibrated one for some reason, whatever,
It's exactly how I did it.
it doesn't, it's legal.
To me it is.
Okay. Just,
There's
No,
no
that's
written
cool.
law that says if you have an inside micrometer, you just have to use your head and go, okay, I need to know what that is and I need to use something that's calibrated. I could put this in and read it, but I don't trust it. What could I do to verify that this is that? Oh, this has been calibrated. Oh, there we go. This reads that. I'm good. So now I've just calibrated this, in theory, and I could use that. But as soon as I take this end off, put something else on, it's not in calibration anymore. Also, there's a little stick that goes in there if you want. I hate the stick. Let me show you. All right, inside micrometer. What does this inside micrometer read? 0.2. Well, it's going to be some inches, but that's probably 1 inch there. We'll just go with the 0.2. We got point. Well, you could look at it one of 2 ways. I only see 2 lines on there.
but you got 0.
I only see 2 lines, so that's 0.50, right? And then that went all the way around again, so that makes it 0.75. So 0.075, so that's 0.275 is what that measures exactly. Everybody should see that. Yeah, good? Okay. This is not a micrometer. This is my opinion. We had, not my opinion, a fact, in my shop, everybody has these. I have one of these. I have two of these. One is digital, one is this way. These are a wonderful tool in aviation for measuring a nominal thickness. And what I mean by that is, if I have a bolt that's either a 1/4 inch bolt or a 3/16 bolt, and I don't know which one it is, this is perfect for that. It'll get you close, and you're like, yeah, great. All of our dial calipers in my shop all had printed on the back a little sticker for reference only. We never calibrated them. They're too flexible, and so so I have a piece of sheet metal. Oh, I don't know, is this piece of sheet metal 032 or 040? Stick that on there like, it's 032. So this works good for identifying something that has a set thickness. 1/4 inch bolt, 3/16 inch bolt, 032 aluminum. But the way you read them is right here. You read it on this edge right here. Everybody see that edge right there? Okay, so there's the 1 inch mark right there. So it's 1 inch, 0.1, 0.2, 0.3, 0.4. So it's 1.4. It's down here on the bottom, but 1.4. And then we just read the dial. That's 50, 51, 52, and some change, 52.8. 528. 1.4 and 528. Got it? And these are kind of cool because you can measure in all different ways. You can use these up here for measuring inside diameter. Like it would go this way, measure the inside diameter of that, or you can use the jaws here to measure something, the outside diameter, or you have the stem there that drops down in, you can measure the depth of something. This is a veneer style. They're a pain in the butt. For me, I actually need a magnifying glass anymore. I used to have really, really good eyes, but now I don't. But if you have a veneer works on what we just learned, basically. You're just taking what we already learned and putting it all together. So where are we going to read this thing? We are going to read it right over here. So we have, here's my 0 line. So we have, here's the 1 inch. I wrote it over here to help out. It's less than 1 inch because we have to see the 0 right here. We're going to read it right here. Right there's our reading line. So we've got 0.8. 0.8, then 2 more lines, which is
0.02, 020.
0, 2 lines. 0.50, and some change. Well, how much is that change? Look at the veneer scale. It's very small printing, by the way. That's 12. So at the 12, 8, 50, 12.862. I will not test you on this right here, but just in case you have to read one, there you go. All right, you are responsible for knowing how to read that and not doing that. What are my don'ts? Do not put in vise. Don't use it as a vise. Calibrate. How do we know if our micrometer's calibrated?
If you close it, it should say 0. If you open it,
Well, what about this one? It's not going to close.
well, it should say the minimum measurement that it gets.
Well, I picked it up. Has it been calibrated? When was it last calibrated?
Hopefully a year ago.
How would I know?
You get the standard? Yeah, use a calibrated standard.
Well, the standard won't tell me when this was calibrated.
Keep a log of it.
Should have a sticker on it. So anything that's been calibrated has a calibration sticker. Has who calibrated it, when it was done, and a due date. So due date they'll default to 1 year unless you tell them something different. So it has a sticker. This doesn't have a sticker, so what do I have to do? Got to calibrate it. I'm responsible for that. All right. Calibrate at least every, okay, annually. Not annually, that's annually. It's something different. Let me see. Do not store the 0 to 1 in closed position. So the 0 to 1, don't close it all the way up, because as the temperature changes, if you've got it clamped all the way down, even if you're really nice and closed it all the way down with the little, there, it's just a little kiss, like you're kissing your sister, just in there. You guys know what movie that's from? I have a whole reel of things that I have to play to see, you know where I get my things from. Well, this thing is way off. It is at 3.5 thousandths when I close it up. Is that good or bad? That is not good. So this needs to be fixed. All right, so should have a sticker. Don't close it. Leave a little space for heating and contraction so it doesn't get all out of whack, which this one is out of whack. All right, what else do I have? Do nots. I don't know. Is there anything else? Do not, do's. Let's see. Nice, right. Oh yeah, and make sure use the ratchet. It's not a negative, it's positive. Use the ratchet. So you don't over tighten. Do not over tighten. All right, one of your tasks is going to be to evaluate and measure parts. One of these parts and one of those parts. A cylinder and a crankshaft. Never remember if I start that or not. All right, and then you have to evaluate what you measured. So I'm going to help you with just one of these things. So, all right. Let's hope that doesn't fall. Two to 3 inches. Who's my volunteer? Come on up. You gotta go quick. Time's money. All right, these have oil holes on them. There's an oil hole right there. There's one right there. Do not stick this in the oil hole. That gives you a bad measurement. And when you do it, you're going to be measuring 90 degrees, like once here and once here. So I just go off the hole a fair amount. You don't want to get, because it kind of tapers into the hole, so make sure you're off the hole right there, then 90 degrees to that. So I'm going to have you, but I'm just going to do it 90 degrees, right like that. You're going to measure this right here. There we go. What do you got? 0.8. 0.8.
0.075.
Hang on. 0.8. 0.075.
And then 0.022.
0.22.
4.
It's 4. All right, let's see if I agree with this here. All right, 0.8. I don't agree. I wish I wouldn't have unplugged that. Problem is, you got the 8, and you do see a third line, but it's coming up on.
Oh.
So that's not 75. It's 0.50. Wish I, yeah, you got, that was a good one to show you. That's a really nice one. Yeah, wow, I screwed up. Actually, all I have to do is plug it in. Everybody see that? All right, thank you. All right, well, I'm not going to need that anymore. See that? There we go. See what he's looking at? So what do you get? 8. See how that 75 line is pretty predominant? Yeah, so it's real easy to see that, but it's only on 22. So it's coming up on the 25. So it's 0.8, it's 0.5050, 22, and then you said 4. We can go with 4. It's got a veneer scale. Let me see, 1, 2, 3, 4. Actually, the 3 lines up a little better, but we'll call it 4. So what do we end up with?
It's a 2 to 3.
7.2.
It is a 2 to 3.
2.8724.
2.8724 is what we got. All right. What I just measured, or he measured, was the rear main journal. They even have a picture for you. Front, rear main journal right here. So we've got one measurement at 0.28724. Then we're going to get another measurement, 90 degrees to that. I'm just going to fake it a little bit. And we'll put it right there. And I got 22. So 872. So I've got 0.8, 0.050, and then 0.022 even. So that's 2.872. Everybody follow? Okay, so I got 2 measurements.
So is that a 1 to 2 or 2 to 3?
I'm sorry, it's a 1 to 2, so it's 1 point. 1 point. 1 point. 1.872. So I have 2 measurements. 1.8724, 1.8720. Which one's smaller?
Second
We need a consensus.
Second one.
Second one is smaller. Is this crankshaft going to get bigger or smaller as it wears? Smaller. So which one has the most wear? The second one has the most wear. So which one is the worst? The second one. So rear main journal, I'm going to write the worst of the two, 1.872. That is the worst. Now, it says right here, out of round. That's the difference between the two. And what is the difference between the two?
point.
Okay, 0.0004. Did it get better by 4 or worse by 4? It's bigger. It's better. It hasn't worn. Right? It's going to wear. Everybody see that? It starts out life, and these are kind of screwed up, but it's the way it is in the manual. It started out its life at 1.873. When it came out of the factory, it was 1.873. It says that right here. New maximum, 1.873. Follow? Brand new, out of the factory. Then it ran for a while, and it got as small as 1.872. It says right there, 1.872. Went from 873 and it wore down to 872 because 873 is bigger, and it wore down to 872. Follow? Okay. So if it's 872, it's at new minimum. 872, new minimum. Is that considered new?
Yeah, no. It's right at it.
Is it considered new?
Yeah.
Yes, it is. 872 is considered new. Could we call that a rebuilt? If that was our only measurement? Yes, we could. All right. Then it goes back in service and it wears some more and it gets down to 1.870. Is that good or bad? Is it serviceable or bad? It's a black and white decision. Is it good or bad? What's the smallest it can be and still be good? 1.870 right there. Is it 1.870? Is it good or bad? It's good. It's a black and white decision here. It is still good. So anything between 1.873, I did not mean it for it to do that. Anything between 1.873 to 1.872, anything between this and this is called new. Anything between 872 and 870 is called serviceable. Okay, but we had two measurements. This is the way I did it in my shop. Which is the worst? What if we had two measurements? 1.8699 and 1.870. What if we had those two measurements?
The top one's worse.
This one's worse. So which one would I write right here? So if I wrote rear main journal and that measured 1.870, is that good or bad? Is it fine?
No, you would have done the worst one first.
Well, what if I was just looking at it and go, well, measured 870. 870 is?
Oh, service, or it's a service, yeah.
So we move on, don't we? We got a good crankshaft. And I said, oh, but it's out of round. How much is my out of round? 001. Is that acceptable? Dad, we got a good crankshaft, don't we? Number one, it measures 870. That's acceptable. And the out of round is only 1/10,000th. And that is within new, serviceable, or out of limits.
So can the out of round go either way?
I'm just giving you an example here. Just stick with me. Is that, looking at those two numbers, would you accept this crankshaft?
Yeah.
Yes, you would. And is it acceptable? But you know the whole story. Is this crankshaft good?
No,
It is not. Why not?
because the lower measurement's beyond it.
Because we never mentioned this one right here. Don't do that. We never mentioned this number. So this is not the way to do something like this. When I do it, write the worst case scenario. What was my worst case scenario? 1.8699. So it measures rear main. 1.8699. Is that new or serviceable or out of limits? Then I'd put out of limits. And what was my out of round? 0.0001. But it got bigger by that much. So I'll put a little plus right there. That's just the way I did things. So anybody looking at it goes, oh, the smallest measurement he got was 8.8699, and the outer round got a little bit bigger. Now, I guess you could have wrote 1.870 and then minus 001, but then somebody's got to look at it and go, oh, what is, that's a bad way to do it. So this right here would be new. What if we measured the front main journal and we got 1.871? 5. Yes. You're very demanding. I should just give you the remote. You have a button right there. You just push it. Okay. What if I had just a measurement 1.8715? New serviceable out of limits. 1.8715. It is serviceable. Everybody see where I'm getting these from? Okay. Because this is going to be your project. This is what you're going to do. All right, moving on then. If everybody's got it?
I don't get it.
Okay.
Why don't you call it service minimum? Because you go below minimum, no out. Service maximum means that.
Why do they call it that? Because there's other things that it'll make more sense. So some things are inside, some things are outside. You just get used to it. You just have to look at the numbers and go, those are the numbers. And you have to think about what it started life at. It was started at 8730, wore to 872, and then wore all the way down to 870. Don't get hung up on the words.
So they're just saying that it could come out in between those two? Like always, it could just be in between those two numbers?
It really could when it was new.
Yeah.
All right, so where did I lose you?
We measured it at 1.8715.
I just made up a number.
But the service maximum is 1.870.
Uh-huh. So let's look at this. estate here. We're going to take those numbers and we're going to move them around a little bit. Same numbers, 1.873, 1.872, 1.870. So anything between these two is new, NEW, and anything from 872 over to this one is serviceable,
Okay.
right? And so I had 1.8715. Where does that go on my number line?
Service.
Well, it's going to go right about here. So I made it serviceable. If I had 1.8721, where is that? Well, it's right there, so it's new. Okay? But don't forget, you have to do out around. Always write the worst case. On this, it gets smaller as it wears. So if you have a 1.871 and 1.872 are your two measurements, which one would you write down as the worst? 871 is the worst, and the out around is going to be plus 0.001, indicating that it got bigger by 1.
Is there an industry standard for that, or is that just kind of up to the mechanic?
That was my standard. That's the way I did it. Everybody's a little different. It's the way we did it in my shop. That's why I had everybody do it, so we're all on the same page. Okay, back to here. So we did that. We looked at veneers. We don't need to do it again. We already looked at this one. Okay, now let's talk about measuring inside stuff, which we did just a little tiny bit. Actually, we already did one inside thing. Maybe we'll come back around to that. If you're going to measure a large hole that is large enough for an inside micrometer, I'd use an inside micrometer. There are also these these tools that are called T-gauges. The T-gauge to me is the most ridiculous thing. It's like I don't know. They measure very small inside holes. If you're measuring a small inside hole, such as these guide bores, these things are actually okay. And you have to be very careful with them. You move these little balls. Let me do a big one here. You move these in and lock this in just enough to hold it. And ours have been kind of abused. Do not just untwist it and watch these things pop out, because a lot of times one will pop out and springs come out, and I will make you, well, Kelly particularly will, she'll make you look for it until you find it. And it doesn't matter if you spent the entire day on your hands and knees in the lab looking at the flashlight magnet, but Kelly, I can't find it. I saw her last semester. It's like, well, you got to find it. That's how we do it. And she had a good point. In aviation, when something like that happens, you have to find it because you can't leave it inside of the engine. So you look until you find it. So, all right, so T-gauges. If you're going to measure this bore right here with the T-gauge, I wish you the best of luck. Actually, you can do it. It takes some, and don't do this with that on. It just takes some skill. What I do is I put it in very crooked, hold one side, bring it up until it's level, lock it in, then pull it through, and then I put it in there and see how did that fit. Oh, I got pretty good. It's still a little small, but anyway, you can do it with enough practice. And so then you would turn it around and measure it with a micrometer. So that's how you would do that. If you're going to do the inside of these guides, then it's just pretty much the same thing. You're going to close it up, put it in, expand it, find the spot you want to measure, lock it, drop it off the bottom, measure it with a micrometer, boom, there's your measurement. If it's a small enough hole, the best tool to use is a ball gauge. That's the stuff in the green package. I like ball gauges. I think they're actually a really good tool, but they don't go very big. So you put it in, expand the ball, and if, like this particular one is wore this way, so don't try and pull it up that way. It's just, you've got it down here. Don't try and pull it with small. That's why I pushed it out the bottom.
What's more that way?
The guide.
The guide? So where did you measure at the largest point of the guide?
I would, yeah. You always want them Yeah, you don't want to measure it where it's good. It's like, well, it's good right there, but the rest of it's bad. We always measure what's bad. It's going to wear larger. So now the large number is bad. It's the same way with the cylinder board. Is it going to get smaller as it wears? It's going to get bigger as it wears. So the bigger number now becomes the bad number. All right. T-gauges. Okay, important thing on this one. Ball gauges go up to 1/2 inch. Up to 0.5 inch. So anything bigger than 0.5, you will use a T-gauge. Over or greater than 0.5, I would use it. You have to use a T-gauge. If it's less than 5, I'm going to use a ball gauge. Very important point, because it's like on a test. We'll get to that some other time. When you get into engine class, we'll be using bore gauges. We just don't have enough time to cover it in this class. But bore gauges are a very fast and easy way to go. Feeler gauges, which are thin pieces of metal that have the thickness stamped, and they're for measuring in between two things. Let's see. We already looked at that. Oh, that was it? All right. All right, covered T gauges, covered micro. So, you're up to speed. We know how to read a micrometer. Hopefully. We know micrometers are calibrated at least every year. We know they're calibrated because there's a sticker on it. If there's no sticker, then you need to calibrate it. If we're measuring an inside diameter of a large bore, we can use either a T gauge or inside micrometer. The preferred would be, if you're given that option, yes. Let's see. If it's a hole that is 1/2 inch or smaller, we will use. If it's more than 1/2 inch, we'll use T gauges. Okay. We're going to talk about hardware right now. I'm going to go over quite a bit with hardware. I don't expect you to remember part numbers except for bolts, because that is something that aircraft mechanics are supposed to do. So, all right, so aircraft hardware. Did I get everything on here? Small, resistant, ball gauge, yes, we are. Hardware. Oh, wait a minute. I can do hardware tomorrow. Yeah, let's do hardware tomorrow. So that leaves us back here with just making sure that we're all good to go. Let me see, do I have... Yep, we covered everything I want to cover. Any questions on any of this stuff? I was kidding. I didn't really want any questions.
So when we're measuring the round off point?
The out of round.
The out of round?
Yes.
That's the difference between the two measurements, right?
That is correct. That is the difference between two measurements at the same spot. Let's see. Who's got their lab project sheets? I have them there. Hang on. We'll do it this way. This will be much easier.
About that measuring journals and things on a crank.
Yes.
You can measure kind of, there's like, 1.5 inches or so of journal. Does it wear differently on either side of it? I mean, could you measure multiples? Do you know what I'm saying?
Yes, I do.
Up and down?
Okay.
Up and down lower.
Yes. All right. So for this class, I'm being a little, this is Adobe. Abbreviated in what we're doing. When we get into the engine class, it won't be abbreviated. It'll be very realistic, exactly how you're supposed to do it. So I've changed it just for simplicity's sake. But, like for example, this particular thing here, this cylinder, the manufacturer will tell you exactly how to measure it and what spots to measure it. Light combing, you do a bunch and you take an average. On this particular one, you're going to measure it down near down here near the head. This is the head here, and this is the barrel. So you'll measure it down here. It used to be you measured it here. They change over the years how they want you to do things specifically. But I have you do it right at the flange, just because it's an easy point for you to do, and then I can go back and go, well, we measured at the flange. You don't have to get all the way down in there. It's easier to get down in there with the bore gauge. So with the tools I'm giving you, you can just measure it here, measure it there. So one's here, one's there. Got your 2, you get your 90. Difference between the two is called? Out of round. Okay, so difference between the two is out of round. Let's do it right here. Now on the crankshaft, let's see, like the front main right here, it's pretty long. Right? You can't just measure it right here and call it a day, because the bearing goes all the way across here. So in the field, what I really do is I will take multiple measurements going all the way up and look for the worst this way, then take multiple going this way, and figure it out. I actually end up doing 2 here, so I have front main 1, front main 2, all of my worksheets in the shop have front main 1, front main 2. So I ended up being not 1, but 2 measurements here, 3, 4 plus spots. So there's a thing called out of round. Out of round is the difference between one measurement versus the other. Now there's also a thing called run out. Run out is something completely different. Run out is how bent this is as a shaft. So maybe it rotates like this instead of rotating perfectly around. Or the flange right here may have wobble in it. That is called run out. So what you do is you set it up in V-blocks. V-blocks are just blocks that'll hold it. So you can rotate it, and you'll actually, if I rotate it without poking myself, you'll see that the center main right here is in line with these. So if I was holding it perfectly still, you'd see the center main should run true. And so we'll actually put a dial indicator. Dial indicator is too far. This thing. That's a dial indicator and has a little pin on it. It'll move a dial. I figured you'd do that to me. There we go. That little dial, right, this will move up and down. That'll move this dial around. It'll tell you how many thousandths of an inch. This is moving up and down. Not out of round, but out of alignment. And then, or you can put it on here and see if there's wobble on this flange up here as it goes around. So that is called run out. And out of round is the difference between 2 things. All right, what I want to do real quick, the reason why I pulled up the lab sheet was lab sheets. Here we go. All right, so we have the cylinders, same thing. So I'll have you measure the intake guide bore, the exhaust guide bore, and the cylinder opening. I have you do it 1 inch from the opening. I specify exactly where I want you to do it from. So in this case, we have, what did it start life out as? What measurement? Mm-mm. So if that was true, 4.064, what? They make it 0464, then it gets a little bit smaller, then it gets bigger? So what's the smallest number on there? So where did it start its life out as? 6.2. Then it went to 4. Then it went to 6.9. So it's the same. See, that's new minimum, new max, service max. It's the same setup as we looked at before, but because of the way it wears, you have to rearrange the numbers. So you have to be kind of smart enough to look at the numbers and go, wait a minute, it went 6.2, then 6.4, then 6.9. 6.2, 6.4, 6.9. But the crankshaft is a little bit different because it wears smaller, so they had the smallest, biggest serviceable this way, then that way.
Because they didn't want to put it in their column?
Exactly. Well, the columns are very long. There's a lot of parts. I just took a small snapshot of it and put it in here. So, but I kept it the same way they do because that's the way it is. You know, at one point I thought about, I even started, I think, on this class. I'm like, I'm just going to rearrange it so it's easy. I'm like, no, I'm not. This is what we have to deal with. So get used to it. Yeah. All right. So we're going to take one measurement one way, one measurement the other way. We're going to write the biggest or the smallest measurement we get.
The biggest is the worst.
Biggest, the worst. And then so this one would be, well, I don't know if I can write on this. No, I can't. It's PDF. So then this one will be the difference between the two, which should say out of round, which is going to be a minus number. How much smaller did it get? All right. That's it for today. I'll meet you across the street.